According to our current understanding, the universe began about 13.8 billion years ago with the Big Bang. This implies that if the universe has existed for 13.8 billion years, then the maximum distance light could have traveled since then would be 13.8 billion light years, assuming space wasn't expanding. However, when scientists mention that certain stars or galaxies are 20, 30, or even more than 30 billion light years away, it raises a natural question. How is it possible for objects to be farther away than the light travel distance since the beginning of the universe? Expansion of space versus objects moving through space. When we talk about distances in space, it's important to differentiate between objects moving through space and space itself expanding. According to Einstein's general theory of relativity, space is not static. It can expand. In the early universe, space has been expanding continuously, which means distances between objects have been increasing over time, even between objects that are not themselves moving relative to each other. This expansion is described by the metric expansion of space, the speed of light, and the expansion of space. You correctly noted that nothing can travel faster than the speed of light, which is true for objects moving through space. However, the expansion of space itself is not limited by the speed of light. This allows galaxies to appear to be receding from us at speeds greater than that of light due to the expansion of space, not because they're moving through space faster than light. This is why we observe distant galaxies moving away from us at an accelerated rate, a phenomenon first discovered by Edwin Hubble and later confirmed by various cosmological observations. Observable distance and cosmic distance. Due to the expansion of space, the distances we measure are not static. A galaxy that emitted light billions of years ago might have been much closer to us when it first emitted that light. But due to the universe's expansion, the galaxy is now much farther away. Therefore, while the light has been traveling toward us for, say, 13 billion years, the galaxy itself could now be located at a greater distance, due to the stretching of space over those billions of years. This stretching has led to what we call cosmological redshift, where the wavelength of the light is stretched and shifted toward the red end of the spectrum as space expands. Current position versus light travel time. So, when we say an object is 30 billion light years away, we're often referring to its current position due to the expansion of the universe. The light we observe from it today started traveling billions of years ago, but as space has expanded, the distance between us and that galaxy has also expanded. This means the actual distance between us and the galaxy can now be far greater than the light travel